Hello, I'm Laia, the Chief Science Officer at Ingenii. Our mission at Ingenii is to accelerate the adoption of quantum computing and quantum machine learning within life sciences. And one of the challenges that we've encountered during this process is that with quantum computing, not only do you need to find the right solutions to the problems, but you also need to find the right problems that are suitable for quantum computing and quantum technologies. And this is why we've designed our tool called the Ingenii Quantum Innovation Lab to help researchers and data scientists discover the use cases that have potential for quantum technologies without having to spend a lot of time and resources. We have already built the MVP of the Quantum Innovation Lab, and today I'm going to show you the main features of this tool. We have divided the use case discovery into different phases. The first one is the discovery framework, where you will bring some different ideas of potential use cases that could be useful for quantum technologies. Then you will be able to build your own use case and go through a series of impact and technical assessments to assess the suitability of quantum technologies to your problem. And finally, you will be able to share your use case with the community so that you can get feedback from peers and potentially collaborate in projects with them. So let's start looking at what these features provide. First, we have the discovery framework. This is a very simple section where you have a space to write different ideas of potential use cases. So the idea here is that you can just brainstorm and come up with multiple ideas of problems that you would love to solve and that would provide a significant impact in your organization by solving them. So here you have a series of questions to help you brainstorm, and here you have a space to write your ideas. Okay, this is the discovery framework. And now that we say we have picked one idea, we can go and build it and understand the impact and technical suitability of my new idea. So here in my use cases, you can see that I have a set of use cases that I have already built. And now I can create a new one. So here, if I click on create new, I can add a use case. So we're going to write an actual example. So let's say that we want to optimize patient certification in clinical trial design. We can write the name here. And then we can use this space to add more information about our idea, which can be useful for yourself, but also to help others understand exactly what you want to do. So in this case, the goal here will be to minimize the discrepancies in the first and second moments, so means and variances and covariances of patient attributes across the different control and treatment groups in the clinical trials so that we can produce better balanced distributions across those groups so that there are no biases in the distributions. Okay, so this is our idea, and we're going to go ahead and add this use case. Now we see that the use case appears here in the list of my use cases, but we haven't actually started doing the impact or technical assessments. So if we go ahead, we can click on edit. And we see that we can edit the name and the description as we wish. And here in the impact assessment, we can actually start going through the impact assessment. So this leads us to a form that will ask us several questions regarding the potential impact of this solution. This means what would it mean for us to solve this solution in our organization. This is supposed to serve as a go, no go decision maker to see if it's even relevant to go to the technical assessment. So for example, in this use case, I would expect reduced computational time and improved performance of the division of the patient in different groups. This is actually a problem that has a significant annual cost related to it, and the returns would be measurable immediately if we can solve this problem. And then these problems would affect our organization because it would improve financial predictability and also enhance profitability because it would allow us to create better clinical trial groups for the clinical trial design, which would increase the odds of having successful clinical trials. And yeah, this if you wanted to solve this problem classically, there's a limitation in data volume and complexity, because it's a combinatorial optimization problem that scales very poorly with the number of patients. So if we did solve this problem, we could indeed handle larger data volumes and do like faster data processing. And while in the next year, in the next few years, there might be an increase of data volume, but it's not like very significant. So I'm going to click moderate here. And yeah, if we wanted to solve this problem classically, this would we would need to invest in computational hardware, like classical hardware. So yes, moderately. And this would indeed create a substantial advantage compared to competitors, because it would allow us to have more reliable clinical trials. So this would be indeed an innovation, increase scalability plan with the number of patients, and increase performance in the clinical trial. And how hard would this be to replicate? I would say that this is moderate. And once we achieve this competitive advantage, it's very long term. So yes. And finally, how would this problem impact our organization positioning? Well, it would definitely increase operational efficiency, demonstrate technological leadership in our sector, and yeah, and enable the product to reach the market faster, because the clinical trials would have a larger probability of success, so the drugs would potentially go faster to market. So after I finish this this impact assessment, I can click to submit, and in a few minutes, 2 or 3 minutes, we will get the report of this impact assessment. After a few minutes, we will see in the impact assessment section that we have our impact report ready. So in this report, in this example, we see that we have high impact for the scalability of the solution, also the financial impact, which is related to having a high competitive advantage compared to competitors. And also in this report, we can see some supporting information related to the answers of the questions that we gave. So for example, the fact that there's a significant financial cost associated with this problem, which will lead to financial returns upon solving these issues, such as the boost of profitability and improving financial predictability. So once we have finalized the impact assessment and we have seen that there's a high impact associated with solving this problem, we can move to the technical assessment, which will assess whether this problem is suitable for quantum technologies. So if we click here, we're going to start a technical assessment, which also consists of a series of questions related to our problem. So in this case, it is an optimization problem, because we want to learn how to divide problems into different groups, and there are many possible combinations, which leads to this being a combinatorial optimization problem. So here we have a series of questions related to the exact nature of the problem. So for example, in terms of decision variables and the size of these decision variables, this problem is large because it has hundreds or thousands of variables typically related to the number of patients. And then this problem also grows exponentially with the number of patients, because the solution space grows combinatorially with the number of patients. And then this problem is also very highly sensitive to improvements, because even a small improvement can lead to the clinical trial succeeding instead of failing. So even very small improvements are relevant to this problem. And then classical algorithms scale poorly at scale with the number of patients, because, yeah, as I said, this problem scales exponentially, and also it is a well-known NP-hard problem. So that it lacks like efficient classical algorithms to find like optimal solutions at scale. And it is indeed a combinatorial optimization problem. And then the variables can be represented as binary variables, because you either assign a patient to a group or not. And then since I know the objective function, because here the goal is to minimize the means and variances of the discrepancies of the two groups, this is clearly a numeric objective function, and it can indeed be represented as a linear and quadratic objective function. So yes, it directly maps into a quadratic function. So we can then go on, click submit to the technical assessment, and again, in a few minutes, we're going to receive the report. After a few minutes, we see that we receive the technical report in the technical assessment section. This report starts with a graph depicting the suitability level of different quantum algorithms. So in this case, we have high suitability for hybrid annealing and also quantum annealing, and medium suitability for variational algorithms. Here below the graph, we can find some supporting information regarding the suitability levels. So for example, the problem is extremely large, which is beyond the scope of most of quantum computers today, but quantum-inspired and hybrid methods might still offer some value. And because computational complexity is the major challenge of this problem, quantum computing and hybrid optimization can provide some advantage, and quantum annealing and hybrid methods are the ones that are most likely to provide near-term advantage. So if we go to the next page, we have some more supporting information and then the recommended algorithms for solving this problem. So if we start with the first one, the quantum annealing one, it has high suitability. And here we can see a brief description of the algorithm, of how it works, and then recommended actions for next steps. At Ingenii, we have a set of quantum machine learning courses to help you get started, and also a Python library that abstracts the complexity of some of the quantum algorithms. So we direct you to some of these courses and the chapters where you will learn to formulate this problem as a QBO problem and use different quantum and quantum-inspired techniques to solve it. And you can also read different papers that analyze how to encode these problems and solve it with quantum annealing. And then we can also direct you to different quantum providers. For example, for quantum annealing, we suggest using D-Wave quantum computers, or also other providers like Quantinuum and Pascal, and Amazon Braket that provides access to multiple types of quantum computers. And finally, to compare your performance with classical optimizers, we also direct you to different classical optimization methods. And then we also suggest using hybrid quantum classical annealers or quantum-inspired methods, because these methods are also expected to have high suitability for your problem. Again, we find a description of the algorithms, how it works, and then different recommended actions and next steps for these methods as well. So with these impact and technical assessments, we hope that you get a better idea of which use cases are most suitable for quantum technologies in the shortest term. And this tool is still in its MVP version, and we want to learn how to make it more useful for its users. So we would really appreciate if you could give us some feedback, tell us what was helpful about the tool, tell us what was missing, what you would like to see in the future. So after completing the impact and technical assessments, you can also choose to share these use cases with the community to get some feedback and maybe form teams for future collaborations. So in the sharing settings, you're going to go and make your use case public so that you can then share it with the community. So if you click Save and Close, your use case will become public for our community. So here now in my use cases, we see that we have completed the use case regarding optimizing clinical trials for patient stratification. So now we can go on and go to the community use cases to see what other people have submitted and made public. So if I go on and find a use case, I can see that there are a few use cases of different community members. And now another thing that I can do is go ahead, read the name and description of the use case, and also take a look at the impact report and algorithm suitability. And if I like this use case, I can also provide feedback to the author. So for example, this use case is related to doing feature filtering for early osteoporosis risk detection with quantum enhanced methods. So for example, this feature filtering, feature selection, this might also be very relevant for the clinical trial use case that we created, because designing and finding the right features for optimizing the clinical trials in different groups, that is very relevant to the success of the clinical trial. So if I go ahead, I can actually add a new comment for this use case. And I can add a comment saying that this is a relevant use case for clinical trials as well. And then I can add a tag to this comment. So this is indeed an opportunity because this is a comment related to using the same algorithms or idea of the use case, but for another problem. So here I can tag this as an opportunity and submit it. I could also tag this as a praise or as a concern, like as a question. How would you solve this? How would you solve that, for example? So here, after I've created this comment, I can click on submit. And the author of this use case will receive this comment. So if I click save and exit, I will have added a comment on this use case. And now the last feature I wanted to show you today is the community members that have their own interface. So if I click here, I will see the profiles of everyone who made their profile public. So now, for example, she was the author of this use case. I could see her details and maybe decide to connect with her on LinkedIn or contact her for a potential collaboration. And if you want to update your profile, you just go into your account details and you can add tags, your bio, and even a profile picture showing who you are. This is all for today. I hope you find this demo useful and thank you for being part of the quantum revolution.